Function composition. This is probably something a little bit new, so let's take a look at the definition. It says composition of two functions f and g is denoted this way, f with a little circle g of x, okay? And that means f of whatever g of x is. Okay, so to make this pretty simple, you're going to take your x, you're going to plug it into whatever's closest there, g, and you're going to get an answer. And you're going to take that answer and you're going to plug it into f. So it's kind of an assembly line process. It's not x going into both of them and then doing something with those two answers. It's you plug it into one, get your answer, and then move down the line to the next function. Let's take a look at some examples to illustrate. F of x is 5x plus 2 and g of x is x squared minus 3x. Okay, so f of g of 2. I'm going to take my 2. First thing it goes into is what's closest, g. So I'm going to put it into this x squared minus 3x rule, and that's going to be a negative 2. Then I'm going to take that answer, negative 2, and I'm going to plug it into the f. So the 5 times negative 2 plus 2, and we're going to get a negative 8. What if you switch it and you say g of f of 2? Well, it makes a difference because this time I'm going to take my 2 and I'm first going to plug it into the f, that 5x plus 2 rule, and we're going to end up with a 12. Okay, now I take g of that 12, so I take that 12 and put it into the second rule, x squared minus 3x, and I get 108. Very different answers. Your note for yourself here, when I do function composition, the order matters. What about f of g of an x? So we're not given an actual numeric value. I do the same process. I figure out what's g of x. What would that look like? Well, they told me right here, x squared minus 3x. So we're supposed to figure out what is f of the x squared minus 3x. So I'm going to take this whole expression and I'm going to erase the x up here in f, and I'm going to put that x squared minus 3x in its place. So it's 5 times the x squared minus 3x, that replaced the original x, plus 2. Distribute and we have our answer. And again, if we reverse the order, it's going to make a difference. So g of f of x is equal to g of 5x plus 2, because that's what f of x is. Now I'm going to take this and put it into g's rule, which said take your x and square it. So we're going to take our 5x plus 2 and square it, minus 3 times whatever you've got here, so minus 3 times the 5x plus 2. I have to note also that when I have a binomial like this that's squared, I don't just simply distribute and square both of those. It means 5x plus 2 times 5x plus 2, which means, as my note says here, I got a FOIL. Okay, and you're going to end up with a trinomial, 3 terms there. Distribute your negative 3 and then combine your like terms for your final answer. Let's take a look at another example to illustrate. In this one, we have f of x is equal to the square root of x, and g of x is equal to 2x minus 3. So what would f of g of 5 be? It's going to mean 5 goes into g. Okay, so 10 minus 3 is 7. And then we want f of the 7. We're going to take the answer and plug it into the other one, and we get the square root of 7. F of g of negative 3, we take the negative 3, put it first into g, so 2 times negative 3 minus 3, we're going to get negative 9. Then we take the negative 9 and we put it into f, and we go, uh-oh, square root of negative 9, not a real number, okay? What that tells me is this original thing that we started with, negative 3, is not in the domain of my composite function. We're going to look more at domains in another segment. What about g of f of 16? Now you notice I switched the order here. So 16 is first going to go into whatever f is, the square root function. Square root of 16 would be a 4. So now I'm going to take g of the 4. I'm done with the 16. G of the 4. I'm going to put that in up here. 2 times 4 minus 3, and we get a 5. I can also do this if I have just straight variables and not numeric values. What's f of g of x? Well, figure out what g of x is. It was the 2x minus 3, right? And then you're going to put it into the f function. So you're going to take this expression for g, and you're going to replace the x here with that g. So we simply get the square root of 2x minus 3.